The purpose of this video is to spark inspiration within the younger generation to be more innovative, creative, and hopefully pursue a career in the chemistry field. A transistor is a switch without any moving parts. Instead of moving parts, it's controlled by electricity. Therefore, it can be turned on and off faster than your light switch at home. The reason transistors are great is because they are very tiny. The average phone has about 100 million transistors in it. How is a transistor made? A transistor is made of semiconductors, mostly silicon. A semiconductor is a material which can be either a conductor or an insulator. A conductor is a material which allows for electrons to flow through it freely. Gold, for example. An insulator is the opposite. It doesn't let electrons to flow through it easily. Rubber, for example. A semiconductor by itself isn't very useful in a transistor, but with the help of doping, it goes from 0 to hero in terms of usefulness. Doping is using a foreign substance to improve performance. The first thing that comes to mind is probably athletes doping, and this is the same concept but on the atomic level. An impurity which has a similar structure to silicon is inserted into the silicon's crystal lattice. The silicon atoms in the crystal lattice are connected by covalent bonds. When the impurity is added to the lattice, it displaces the silicon. If an impurity with an extra electron, such as phosphorus, is added, there'd be an extra electron floating around the lattice, which increases the overall conductivity of the silicon. This is called N-type semiconductors. If an impurity with one less electron, such as boron, is added, there will be an empty place in the lattice. Electrons will move into the empty spot, but the spot is said to move because there are less spots than there are electrons. The spot is a lack of an electron, and therefore it acts as if it were a positive particle. This type of doping, p-type, also increases the conductivity. A transistor is made by sandwiching one type of silicon in between the other type. The emitter supplies the current and the collector receives the current when the transistor is on. The base is the silicon between the emitter and the collector. For example, a PNP transistor has the N-type silicon in the middle with the P-type silicon on both sides. One P-type is the emitter and the other P-type is the collector. The N-type is the base in the middle. In an NPN transistor, the P-type silicon in the middle is the base, and the N-type silicon on both sides are the emitter and collector. Both transistors work in the same manner. How does the transistor work? In an NPN transistor with the switch in the off position, the current is unable to pass through the base due to the depletion layer. The depletion layer is the place where the base meets the collector and the emitter. The electrons from the N-type diffuse over to the P-type, making one side positive and the other negatively charged. When a current is passed through the transistor, the negatively charged side repels the electrons. This prevents the current from flowing through. To turn the transistor on, a positive current must be added to the base, which shrinks the depletion layer and attracts electrons in order for the current to pass.